There are infinite variations of lines that we can draw on the Cartesian plane. However, they all have two major defining components. First is the angle at which the line is moving, called the slope. Second is where they cross the y-axis, called the y-intercept. You probably have experience handling the slope-intercept form of a line, where y is the output, x is the input, m is the slope, and b is the y-intercept. But to fully understand linear equations, we must inspect the slope and the y-intercept a little bit closer. If you remember slope from high school, it was described as m, or rise over run, or the change in the y direction over the change in the x direction, or even delta y over delta x. If we look at what this means visually, what we're going to do is consider 2 points on the line and create a right triangle out of them. We find the lengths in the vertical direction and the horizontal direction, and then divide the vertical component by the horizontal component. So for this line, the slope would be 2, and the y-intercept would also be 2. So the equation of this line, in slope-intercept form, would be y equals 2x plus 2. In general, if our line is going up, read from left to right, then the slope will always be positive. Let's compute the slope of this line. Notice how when we compute the vertical component, when reading the graph from left to right, it doesn't actually rise or go up. Instead, it actually sinks or falls down. So what we do is we attach a negative sign to our length. This makes our slope minus 3 and our y-intercept 2. In general, if our line is going down, being read from left to right, then the slope will be negative. If our line is horizontal, the slope will always be 0. This is because there is no vertical component, resulting in a 0 in the numerator of our slope formula. If we have a vertical line, that means there is no horizontal component. This is a problem, since it results in a 0 in the denominator of our slope formula. And remember, we can never divide by 0, so we call this slope undefined. A vertical line will always result in an undefined case, and is usually written as x equals something rather than y equals something. If you rearrange the slope formula by multiplying both sides by the denominator, we arrive at what we call the point-slope form of the equation. Let's see how we can use this formula. We are given that the slope is 4, so we can substitute 4 for m. But how does this point, minus 1, 3, help us? Well, remember, what is an ordered pair? It's a set of numbers that make the right-hand side of the equation equal the left-hand side. So they're saying that if we input minus 1 into our linear equation, we should get an output of 3. So let minus 1 equal x and 3 equal y. Now what we can do is solve for the y-intercept. First we have to find the slope. We need both points to do this. It doesn't matter which point you choose for xy or xy with subscripts. Just make sure that you're keeping the same y's with the same x's. We use algebra to solve for the slope, which is 3 over 2, after the negatives cancel out. Now to complete the point-slope form, I plug in either of our given points. It doesn't matter which one. To find the slope-intercept form, rearrange our equation. Another quality of linear equations is that if there are two lines plotted on the same Cartesian plane, they will eventually intersect at some point, unless they have the same slope. If two lines fit this property, they are said to be parallel. We are given a line that looks like this, and we want to find the equation of another line that crosses this point and is also parallel. Since they are parallel, we know that they have the same slope. This is a good starting point for us. We are also given that the second line passes through the point -2, 4, which means that if we let -2 equal x and 4 equal y into our equation, we can now solve for b, the y-intercept. So our final answer is y equals 3x plus 10. The equation of the first line is given to us in what is called the general form. It can be a little bit difficult to tell what the slope is like this, so what I'm going to do is convert it back to slope-intercept form. And I'm going to do this by solving for y. I get y equals x minus 5 over 2. Since we know that the lines are parallel, they have the same slope. This means for our parallel line, the slope is equal to 1. All we have to do now is find the y-intercept by plugging in the given point, -1, 3. Our final answer is y equals x plus 4. Now we know that two lines plotted on the same Cartesian plane will always intersect unless they are parallel. But we should also mention that there is a special type of intersection that is very useful to mathematicians, and that is when they intersect at a 90-degree angle. If two lines have this property, they are said to be perpendicular. If the slope of line 1 is equal to m, then a perpendicular line has a slope of -1 over m. This is known as the negative reciprocal. Given this line, we are trying to find another line that intersects it at a 90-degree angle and also passes through this point. Since line 1 has a slope of 1 over 5, then we know that the perpendicular line has a slope which is a negative reciprocal, which is -5. Now we have to find the y-intercept, and we're going to do that by using the point that was given to us. Since the second line is perpendicular, we know its slope is the negative reciprocal, so its slope must be 7. Using the slope-intercept formula, we find that the equation is y equals 7x minus 44.